moderator, and my name is Julia, and I'm here to support the speaker. So it's important for you to know that all questions will be answered at the end. So feel free to raise your hand, and for everyone at home, please write a comment. And yes, but for now, please enjoy, and the stage is yours.
Thank you. And definitely like and subscribe, click the bell for, no, that's a different one. So I'm really excited to show you a bunch of stuff about the internals of Git. We're going to open every file inside of a .git folder and explain what it does. Here's the part where I tell you I am definitely going to post the slides on my site tonight. But in this talk, there are no slides. That's it. So you can hit me on Twitter at rob_rich, and we'll take a look at this gist that is the list of all of the resources that we'll look at. Here's that gist, and remembering that long URL is going to be really hard. So you can head to robrich.org, click on presentations, and here's the definitive deep dive into the .git folder. You can get a link to that gist right away. And of course, somebody from the States is calling to spam me. That's hilarious. So that is, the resources are online right now. While we're on robrich.org, let's click on About Me and learn some of the things that I've done recently. I'm a Cyril developer advocate. If you're having trouble with your data mesh, I would love to learn from you. Some of the other things that I've done, I'm a Microsoft MVP and a friend of Redgate. AZ Give Camp is really fun. AZ Give Camp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver that completed software back to the charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ Give Camp. Or if you'd like a Give Camp here in Munich, or wherever you're connecting from, then hit me up on email or Twitter, and let's get a Give Camp in your neighborhood too. Some of the other things that I've done, I did a lot with Gulp in version 2 and version 3. And one of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comments on the air, and they sent me a mug. Woohoo! So there's my claim to fame, is my coveted .NET Rocks mug. So let's talk about Git. Now, our first task to get a Git repository is either to git clone something, or we can also do git init. Let's do that. And when we create this repository, now we have, oh, I'm in the server. Let's go delete that one. And let's do one here in this empty folder right here. So that one's still empty. And we'll come over here to this folder. This one's empty. Git init. Now we've got a .git folder. Now the cool part about it is this is the repository for all of the things in Git. This is Git's database. So if you want to back up your Git database, you can just copy this .git folder. Now I'm here on Windows, and I've specifically chosen to show hidden files, which is why I can see it. On Mac or Windows, you may not see this until you do an ls-la to be able to get all of the files. But once you've got it, then you've got this .git folder. I'm going to open up this .git folder in VS Code, and we can take a look inside of it. By default, if you just open up the containing folder, VS Code is going to hide the .git folder for you, so you won't actually get to see it, which is why I specifically opened up the .git folder inside. Okay, so we've got some refs, we've got some objects, info, hooks. It's pretty empty so far, but we're going to build up some history here and take a look at how it works. So I'm here inside that folder, and I'm going to say echo file1 and redirect that to file1.txt. So if I cat file1, then it just says file1. Okay, let's git add file1. We've now added it to our staging area, and let's git commit -m file1. Okay, we got a commit in our repository. If we say git log, we can take a look at the details, and 2CAF3C7, that's our commit. It was created right now by this guy. And so we can now take a look inside of our .git folder, and we have a few more files that we didn't have before. Here in the objects folder, we have this folder, what was it, 2C? Hey, there's a 2C folder. That's pretty cool. Let's open up the 2C folder. And we've got an AF37C7 file in there. That's cool too. If we open it up, it is a binary file, and VS Code is going to say, are you sure? Yeah, there we go. There's our commit. This is a zlib compressed file. And so, yeah, I can't read it in VS Code. But there's various ways of unzlib compressing this. So, for example, here's a GitHub, a Stack Overflow post that's also referenced here on that gist, where we can say we can use Perl to uncompress it. We can use OpenSSL to uncompress it. That's kind of an interesting use of OpenSSL. Here's a Python script. I wrote a similar script where I wanted to uncompress it. I just called it unzipper. And so here's my unzipper program. And it just goes and grabs my file, reads it, inflates it using this zlib library, and then outputs the contents. I'm going to split it by nulls so that I get different lines, and that will help me understand that content. Okay, so we've got this 2CAF file. From here, let's unzipper. We'll go into our .git folder, and then objects, and then 2C, and then AF, and let's unzipper this file. Here's the contents of it. So we have commit 178, tree, author, committer. Here's the file. Oh, that's my comment. That's what I committed. That's pretty cool. We saw some of this content in our log. That was neat. Tree 0B9F. I seem to remember a 0B folder. Let's go look inside VS Code. Yep, we've got the 0B folder, 9F. Let's unzipper that file. Unzipper 0B 9F. Here's the contents of that file. Now it says that where the other node was a commit node with 178 bytes in it, this one is a tree node with 37 bytes in it. Here's my file name. Here's the file permissions. Some other stuff that is double zlib compressed. Thanks, Linus. But we also have this other one here, this E2 folder. So let's go unzipper that one. Unzipper .git E2. Thank you. Yes, I do need the objects before I get there. And here's the contents of that file. So it says blob6, and here's the contents of my file. I typed file 1, and I put it into this file. So this one is a blob of 6 bytes. Okay, so we have commit nodes, and tree nodes, and blob nodes. That's kind of cool. Let's do another commit. Echo file2 into file2.txt, git add file2, git commit -m file2. And now if we go look in that objects folder, now we have 3 more objects. Wait, I did 1 commit, and I ended up with 3 objects. Yeah, we have the commit node that explains to us the commit history, or the commit message, the author, the date and time. Then that references a tree node. The tree node references all of the files and what permissions they have, and it uses that then to reference the blob nodes that have the actual content. So we could definitely go unzipper them all, but there's actually a git command for this. So let's git log, and we want to look at 355. We can say git catfile -t. Is it -t? Git catfile. Yep, -t, that commit. And that will give us the type of commit. So in this case, it's a commit. Okay, let's git catfile -p to get the contents of that commit. And here's that tree node. So this tree node, it references file2, and here's the parent node, and it references this other content. And so we can now see that that this commit node references this tree node. So okay, let's git catfile -t. That one, yep, it's a tree node. Git catfile -p. It's kind of nice that it double zlib compressed that file for us. We can see that we have 2 files in our working directory at this particular commit. Now here's one file, file 1. We saw that one before, git cat file -t. It's of type blob, and we can do a -p to get the contents. And yep, there's the contents of that blob. We could also do the same thing, git cat file -p for this one. But that was kind of a lot of work to, unzipper them or cat file them. It would be cool if we could, visualize all of them in one place. So there's this project right here, Git Explorer, that allows us to visualize all of the nodes in our .git folder in one place. So to start off, we create this config file that points to our repo folder, not the .git folder, but the folder that contains it. And so I've got that here. Let's, here's Git Explorer, and here's my config file. So let's say npm start, and that will start us up on port 3000. And apparently I forgot to console log that. Oh, it's still doing the TypeScript compile. There we go. Now it's going to start on port 3000. There we go. And so let's take a look at what this site looks like. Now, unlike traditional sites that will only show us the commit nodes and the history of those, this will actually visualize not only the commit nodes, but also the tree nodes and the blob nodes. So here's this one, and here's the contents of it. Oh, that was a tree node. Here's this one, that was a commit node. Here's this one, it's a blob. So let's show the type, let's color them. And I just randomly picked colors. So this one's blue, and this one's red, and this one's green. So let's show them alphabetically, and I'll show their tags. And so now we can kind of see this one. Here's the blue one, it's a tree node, and here's the red one, it's the commit node. We can start to wander through our tree a little bit easier. Now, that's cool to be able to see it alphabetically. Now we can take a look in our directory and be able to visualize the contents. But let's actually view them as parent-child. And I'll show the lines and show their tags. And now I can see, here's the commit node. That's what I saw in my Git log. And its parent node is right here. So there's that parent node. And when I'm looking at this commit node, it references this tree node. So here's this tree node. And this tree node tells me that there are 2 files in my working directory, this file and this file. Now that's kind of cool. I have a new commit that has more files than I had before, but I didn't need to store 2 copies of this one file. The file didn't change, so I only have 1 blob node. So that's pretty cool. We get to kind of visualize what's going on in our repository. So let's add some more stuff. I'm going to say git add, or nope, let's echo file 3, and we'll redirect it to file3.txt. Did we change any of the history inside of our Git repository? Let's go parent-child, show the types, show the lines. Nope, we still have the same 6 nodes. Okay, so let's git add file 3. Did we change those objects? Let's come back in here and refresh. I probably should store the details. Oh, we've got a new blob node. That's cool. When we stage the files, we get that blob inside of our .git folder, in our objects. Now that's great. If we're staging the file and we're staging certain lines and then we're maybe changing other lines, it's going to grab that blob and set it into our repository so that we can keep track of this file. Now we haven't committed it yet, so this blob isn't referenced by any tree nodes, but it is a blob inside of our repository. Okay, so let's git commit -m file 3. And now we've committed that file. Let's refresh our visualization, show the type, parent-child, show the lines, show the tags. Okay, so now we have a 3rd commit, and it references this tree node, and it references this file, and this file, and this file. So this tree node says, hey, I've got these files in that directory. That's pretty cool. We saw how the commit node or the blob node came in when we staged it, and the tree node and the commit node came in as we committed it. Now what happens if we were to, say, create a folder here? Let's create a new folder, and we'll call this folder. And let's come back in here and we'll echo file1, and we'll redirect it to folder/file1.txt. Okay, git add folder/file1, git commit -m in a folder. And now let's come back and visualize this and take a look at the content. Parent child, show the lines, show the tags. Okay, so now we have a fourth commit whose parent node is this third commit. Here's the tree node, and this tree node says, I have these 3 files in my working directory, and I also have this folder in my working directory. Now the cool part about this folder, its tree node is 0b9f, which just happens to be this tree node right here. We had a tree node that worked perfectly, no need to creating another tree node. So there's our second tree node that references this file inside that folder. Now the other interesting thing about this tree node is we're referencing this file right here that is e2129, which is also this file. We committed 2 copies of the same file, and we ended up with only 1 blob. That's pretty cool. The history of Perl is maybe 20 years long, and its .git folder is smaller than the checkout folder for exactly this reason. All of the content is zlib compressed, and we're able to deduplicate content and some other optimizations that we'll get to. It's really cool. We just have this one blob that says, I am file 1, and it's referenced by this tree node and this tree node, and this tree node then references the other tree node. It works out great. Okay, so I'm going to come in here and I'm going to create a new file. Let's say echo file 4 with accidental secrets in it. And we'll redirect this to file4.txt, git add file4, git commit -m file4. Okay, so we accidentally put some secrets in here. That's too bad. Let's come back in here and visualize our git setup. Let's show the type, parent child, show the lines, show the tags. Here's our commit, and it references this tree node, and it references this file node, and oh, yep, we've got some accidental secrets in there. Hey, I know. Let's just remove those secrets from this file. That'll fix it, right? With no secrets in it. All better now, right? Git add file4, git add file4.txt, git commit -m file4, but I'm actually even going to take it a step further and say amend this commit. I'm going to rewrite the previous commit. See, nothing's here, right? So now if I do a git log, I only have 4 commits in here. Let's git log --1 line so that we can see those 4 commits. Yep, there's those commits. Well, 5 commits. My secrets are totally gone, right? Totally all the way gone. Yeah, I pushed them up to GitHub and everyone has cloned them by now, but look, see, they're gone, right? Well, let's load up our Git history again and let's take a look. Show the type, parent child, show the lines, show the tags, show the lines. So here's this commit, and that's where my head is pointing to. So that's the latest tree, the latest commit in my history. And its parent node is this one, and that one is where I only had the first 3 files in the folder, and its parent commit is all, and we have this commit with this tree node referencing this file. Are the secrets gone? Git is this wonderful double entry bookkeeping system that the moment you put your secrets into, it will keep them forever. Don't write your diary in Git. But the cool part here is that the moment that you commit your secrets to Git, they will be stored forever. Kinda. And so the moment that you commit your secrets to Git, you may consider them lost. Yes, we can amend the commit. Yes, we can force push. Yes, we can do all of these things, and our commit is still right there. In time, under the hood, Git will run git gc. And actually, before we do that, let's take a look at the objects that we have in our store. And we have quite a few of them here. But under the hood, from time to time, when Git finds the need to, it will run git gc, which is garbage collection, where it goes and looks for all of the things that may not be attached to anything anymore, that are of a certain age, and it starts to prune them. Now, it does this behind the scenes. That's why sometimes when you type a command and it takes an extra long time, that's kind of what it's doing. And so now, if we come back into our repository, then we can say, show the type, show the parent child, show the lines, show the tags, and by the way, it is right there. Yes, you can do lots of things to try and get your secrets out of Git, and eventually it'll work, but more than likely, somebody has already cloned this, or you've backed it up to the server. The moment that you commit it, in spite of all of your corrective actions, please consider those secrets lost and go rotate them. It's just safer. Now, one of the things that we did do with git gc, though, is we rewrote this objects folder. No longer do we have all of those files kind of loosely set out in interesting places. We now have all of these files in these two pack files. Now, one of them is a pack, and one of them is a pack, an index file. And so Git can read the index file to figure out how to unpack the commits if it needs to. And so it can definitely go in here. So this is a zlib compressed pack of a bunch of zlib compressed commits. That's pretty cool. And so it'll automatically unpack them if they need to be, but that's what the pack and index files are. So we got to look at how our objects are stored here in the objects folder. That's really cool. Now let's look in the refs folder. Now, one of the refs that we've gotten to see a lot is head. Now, head is where our checkout directory is. So right now, it says it points to refs heads main. Here in our git log, if we say git log -- one line -- graph -- decorate -- all, or actually I'll just do decorate for now, we see that head is pointing to main. And if we open up this file, head is pointing to refs heads main. Okay, so let's go into the refs folder. Let's go into the heads folder. And, oh, I rewrote it. I garbage collected it, and so main is gone. Let's go commit something. Echo file 5, redirect that to file 5.txt, git add file 5, git commit -m file 5. Okay, now we'll have a head directory. Refs, heads, main. Okay, so there's our refs, heads, main, our pointer to where our branch, our head went. And here in refs, heads, main, it says DDC7132AA. Hey, that's pretty interesting. Git log -- one line -- graph -- decorate DDC7132. Head points to main because it says refs heads main, and main points to this commit. So what if we pointed main at this commit? The only way that you can break the .git folder is to change stuff in the .git folder, so please don't try this at home, except for this is really fun, so let's try this at home. I'm going to change what main points to. Git log -- one line -- graph -- decorate. Hey, main now points to here. That was pretty cool. Now, if I do a git status, that did really bad things, so let's not do it that way. Let's put it back. And now if we do a git log, then main is where we expect. Head points to main, and main points to a commit. So what if I check out this? Git check out this commit. Now I love and hate this message. You are in a detached head state. So do I have a zombie commit now? You know, this detached head state. Well, what is detached head state? Okay, let's pop open head, and head doesn't point to a ref anymore. Head points to a commit. Now that's okay. We can continue on. We can say echo file 6, and we'll redirect that to file6.txt, git add file 6, git commit, git add file 6, the other one, the one with the .txt, git commit -m file 6, git log --1 line --graph --decorate, and everything worked out great. Except for, because I am here in this detached head spot, if I were to say, I don't know, check out main and do a bunch of stuff, when that git gc ran next time, it would go, hey, I've got this unattached thing. I think I might delete it. Now, it's going to take some time. It needs to get a certain amount old, generally about 2 weeks. But so now I'm in this detached head state. Well, how do I get out of a detached head state? Well, let's say git branch, new branch. And now am I out of it? Nope. Head doesn't point to my new branch yet. I just created this new branch. Let's git checkout new branch. Git log --1 line --graph --decorate. We are no longer in that detached head state. Now, my prompt was telling me that it was mad, but now head points to refs heads new branch. Ooh, we've got a new file, refs heads new branch. Here's new branch, and it points to this commit. That's pretty cool. But here in my history, where's my other stuff? Did I just like lose main? Is it gone? Well, it's here inside my refs heads, and it's still pointing to there. So I can say git log --1 line --graph --decorate. I can add a --all, and it will not only show content in my own branch, it will also show me content in the other branches as well. So now I can git checkout main, git checkout new branch, and I'm changing that head file to point it to different places. Okay, so that's how local branches work, is we just have these files inside the heads folder. What about tags? Okay, so let's say git tag v1.0, and so let's go look at that content. We've got this new tag, it's v1.0, and that is here in the tags folder. We've got this v1.0 that happens to point to this commit as well. Oh wait, I wanted to point this commit to this branch instead. Okay, now my tag is over there. Let's put it back. Tags are also just folders in this refs folder, or just files in this refs folder. Well, how about a remote? So let's create a server. Now, we could definitely create a server up on GitHub or on a file share. Maybe we're using GitLab or TFS, Visual Studio Online. I don't know what they call it now. So let's create a Git repository. Now, last time we said git init, and that created a repository, but it also created a checkout directory. In this case, we want to create a server. So let's say --bear. Now, when we say bear, it's going to create a repository, but it's only going to create the contents of the .git folder. It will not create the .git folder, and it will not checkout directory. So here's that directory. We see we've got refs and objects and head and all of the things that we would want on and expect on a folder, on a Git repository. But if we take a look at it, here's our server. There's no .git folder. It's only the contents of the .git folder. Now, that's perfect for servers. Okay, so back in our regular repository, let's add a remote. So let's say git remote add origin, and now we could definitely say HTTPS some server, or we could point it at a file share some server path, or in this case, I'm going to point it to we could point it at a local file repos somewhere. But in this case, I'm going to use a local directory. I'm just going to say it's up one folder and it's the server. That's where my server is. Okay, git remote -v. Yep, I've got my remote and it's pointed at that server. Let me say git push origin main. I have now pushed my content up to the server. So if we're over here in our server, we can say git log one line graph decorate all, and we will now see all of that content is pushed up to our server. So what does it look like over here? Let's do a git log -- one line -- graph -- decorate -- all, and we now have this origin /main. Okay, back in VS Code, inside refs, we now have a remotes folder. That's pretty cool. Inside remotes, we have an origin folder. That origin folder specifies the name of our remote. We just happen to call it origin. And inside there is a main folder, which happens to point to my batteries. There we go. Happens to point to DDC 7132AA. So that's where I saw the server last. Perfect. Now I don't have a remote yet. Git log -- one line. I don't have a remote yet for new branch. So let's git push origin new branch. Let's git push origin tags. And now we've sent all of those other things up to the remote. So here inside the remote's origin folder, we now have main and we have new branch. And I bet I rushed git to not, oh, it's got the tag, and the tag is in the same place on the client and the server. So we've got that in place. So that's the refs folder, is the human readable labels that we can put on particular commits. And one of the refs happens to be head, which is out here, and that's kind of interesting. So we looked at objects and refs. Let's next look at logs. So I'm cruising along, git log -- one line -- graph -- decorate -- all, and I say git branch -d new branch. And I'm also going to delete it out of my remotes just so that I know that it's all the way gone. Remotes, new branch. So now I do a log. Oh, git branch -D new branch. Now it's gone. Wait a minute. Ah! Here's the part where I rage quit, throw it away, go grab a new git clone and start again. Git reflog or reflog. I'm imagining this cat of nine tails and the DevOps manager going, nope, git reflog. So that will show me where my refs have been. Now in this case, I looked for head because I didn't specify a branch. And so it says head was here, and then it was here, and then it was here, and then it was here. And so we can kind of see it move throughout our history. Now I'm after this 0f6d, and so here it is, 0f63d20, git checkout there. Yep, back in that detached head state, but we know we have our commit still. Git checkout -b, new branch, git log -- one -- graph -- decorate -- all, and we're back. It was still there, and we can use reflog to navigate back to where it was. Now that git reflog command is really cool. What it's doing is it's reading this logs folder and this head file. Now this head file says I started out at this commit and I moved to this commit. Here's the commit message. I started out at this commit and then I moved to this commit, and it's just wandering through all of the places where I went. So you committed the secret, and then you amended the commit out, and then you did a git GC, and then you waited long enough, and then you make sure you didn't push it, and then you purged it. Yeah, I still know what commit it was. I can get back there. In addition to the reflog for head, we also have reflog for each of our branches. Here's the one for main. Here's the one for new branch. So yeah, I probably could have just opened up this new branch file and figured out where I was. Here's where the remotes were. They haven't moved very far because I only pushed once. But that's all of the files here in the logs folder. We also have some other logs. Actually, let's jump out of logs and take a look at hooks. Hooks are really interesting. If we open up this hook file, it looks like a shell script. And that's really cool. In this case, it ends in a .sample, but it is a shell script where it can do some interesting things. Looking at another one, this one's a shell script, this one's a shell script. Oh, this one's a Perl script that will do some interesting things. Now, right now, they're not doing anything because they end in .sample. And so to get a git hook to take effect, we can just rename it to not have .sample. Now, I've gone and grabbed a bunch of hooks here, and I'll set them in place here in the .git folder. And so basically what I did was I took each of these, and instead of having the script that they had, I just have a script that references the hook name and I'm losing my mic. And outputs all of the command line arguments that got us here. So that's pretty cool. We can now enumerate all of the hooks as we hit them and identify which things we're doing. So here's the apply patch hook, the commit message hook, the FS monitor hook, post update hook. So let's do some history and take a look at when those hooks happen. Let's say echo file 7, and we'll redirect that to file7.txt, git add file 7. Nope, no hooks yet. Git commit -m file 7. Oh, we've got a pre-commit hook, a prepare commit message hook, a commit message hook, and those are the 3 hooks that just got executed. Now, in the prepare commit message hook, we got the commit message. That was pretty cool. It told us that it was in this file, by the way. In the commit message hook, we got that file. We also got the git hash and some other things in there. Oh, maybe we just got that commit edit message. And so in each of these hooks, we might get past arguments that we could use to, for example, let's lint our files that we're about to commit, because we have an enumeration of all of those files. Here's that file name that we're about to commit. Let's go quick lint them, or let's run our unit tests. We can do these automated tasks that typically we'll forget to do, but our machines can do them for us. Let's create these git hooks so that we can do those automated tasks and make sure that our code is clean as we push them. I can also say git push origin main. Nope, I'm on new branch. And we'll get to see some more hooks. So we get this pre-push hook, and it tells us the information that it's sending to the server. And so we could, on a pre-push hook, go validate our unit tests again, or, at this point, we've already committed them, so maybe it's too late. But we can also create hooks on the server, and if you've ever done a git push to Azure and used Kudu to be able to automatically deploy your thing, then that's exactly what they have. They have a post-commit hook running on the server that notices you did this commit and takes additional action. That's perfect. All of those live here in this hooks directory. So I've carefully crafted my hooks. I really like these hooks. I want to be able to commit them because, they were really excellent. And so let's come in here and let's say git add.git/hooks/ let's do the apply patch message hook. Git status. Bummer. We can't commit files that live inside the .git folder. Yeah, that's annoying, but it's a thing. So let's look at, I'm not positive I copied this, so let's come in here and let's look at, oh, there it is, Git hooks. Now, Git hooks is an NPM package. There are also packages for Perl. I'm going to go reference my cheat sheet for a second. Git hooks and Husky are in NPM. Pre-commit is a Python script that is also used by lots of other communities. So if you have a C# thing, you can use this Python script. PHP Git hooks, or Grum PHP. I think it might be Grump. The icon is a grumpy old man, which I think is just classic. Git hooks, or Baze's gist, is great for shell scripts. There's also a Go Git hooks, as opposed to the shell Git hooks, which are actually different projects. And you can also then just reference some other folder where you want to symlink your things. Each of these packages, once you install it, will symlink the different folder into the .git/hooks folder. So I might have this other folder somewhere else. You know, maybe I have a .git hooks folder, and now I can commit that folder. So let's go create that. I'm going to say echo, or no, mkdir.git hooks. And inside that git hooks directory, I'm going to go copy these hooks into place. I'll just copy these first few, and I can now put them into this script. And now you'd have to rig up your symlinks, and so that's the beauty of this package, is that it will automatically do that for you. As you npm install this package, it creates those symlinks, so now your git hooks can be committed into your repository. If I now say git status, I can see that I have some content here that I could commit. So hooks are really powerful in being able to do some automation. And so those things that you always forget, create Git hooks to be able to do them for you. Use one of these packages to be able to share Git hooks with your team. So we looked into hooks, we looked into logs, objects, refs. Info is kind of fun. Here's an exclude file. Now I could choose to exclude bin, obj, node, modules, package, lock.json. This is a .gitignore file. Now that's cool. We can definitely put our gitignore file content in here, but git status, that is also inside the .git folder in a place where we can't commit it. So if you want to be really selfish and not share your exclude directory, your exclude list, you can definitely put it here inside the info folder in the exclude list, but I would really recommend that you put it inside of a .gitignore file that you can commit and share it with your team. So that's the exclude folder. The refs folder, this is where my head is. I'm not sure why it has another refs folder in here, but let's start wandering into configuration details, which is pretty cool. Here's a config file. This config file lists the details specific to this repository. Now this config file overrides the settings inside my local, my user-specific Git configuration. So let's go grab that. Here's my user-specific configuration. We call it the system one because naming is hard. And this is where I, for example, set my name and my email address. When I first configured it, I said, you know, go set the global details. Oh, this one's the global one because it's user-specific. And this one overrides the system one, which is the one that I installed when I installed Git. So let's go open that one. Oh, it's fallen off my history. That's okay. Open file. C, program files, Git, etc config. Nope. etc git config. So this is the system one, the one that's installed with Git. This is all of the questions that I answered when I was pushing next when I installed it. And that is overridden by anything that I have in my system one, which is the one in my local profile directory. And that is overridden by anything that I have in my local Git config inside my repository. So let's say I want to create some packages that are mostly for my personal stuff, but I want this one repository to be for my work stuff. Now, I could definitely go back and forth and switch my Git config every time to change my email address to make sure that I'm using my work email address when I'm committing to work stuff and my personal email address when I'm doing personal stuff. Or I can take this user section and I can copy it into this config file. And now I'll change it to cyril.com, and now that's my work folder. Now the cool part about it is if I do another commit, echo file 8 to file 8.txt, git add file 8, git commit -m, file 8, git log. Oh, there's our hooks. Now, previously, these were done to my email address that was specified in my profile config. Now I'm committing inside this repository to my corporate email address. Any other config files that we want to override? Did someone not pick the automatically convert line endings box correctly, and I have this one repository that I need to do weird things? You can definitely come into this config file and adjust them. Now, all these config files have the exact same pattern, and so one of the things that's kind of interesting is I'm usually here in my git config, and I type git, and then I go off and I'm looking at other stuff, and I come back and I type git status, which happens to work just fine. Because I have this really cool alias that I've hooked up in my directory where I say, if I type git, I would like you to execute on the shell git with all the parameters that I pass to it. Which, by the way, makes this work really well too. Actually, status. There we go. The other really fun one that I like is, those are aliases, by the way. Those are really fun. Autocorrect. Now, I gave it the number of seconds, in this case, 8 seconds. But I don't know how many times I've typed git status. Hey, I think you made a mistake. Can I fix it for you? Why, yes. The only one that I need to make a GI command because I often type this, and that's not going to help me at all. But that is the .git config file that allows you to configure your Git repository in really interesting ways. So that's the config file. We talked about head. Let's talk about index, because index is really interesting. It is a binary file, and it is, a whole heap of mess. The format of this file is a little bit weird. Here's a Stack Overflow post that references the format for this git config index. And yeah, it's it's really hairy. If you want to, there's git commands to do this, but Gin is a Python program that allows you to parse this file as well. And so you can take a look at that to be able to look at this content. But there is a git command that allows us to get into it as well. Git ls files, and we're going to give it the -- stage section. Yep. Git ls files. Am I in a? There we go. Git ls files. There we go. I apparently typed stage incorrectly. So git ls files. It's reading that index file, and this is all of the files in my current working directory, and it also specifies my merge status. Now, right now, I'm not merging, so I've got 0 in all of the files, but this is the blob node for each of those commit messages, or each of those files. So when I do a git status, it's going to really quickly go through my checkout directory, create the hash of each of those, compare that to the hash of the most recent commit, and that means that it doesn't need to traverse this folder anymore. That's pretty cool. That's what this index file is. There's also a description file. This is the description of the website if you're using Git InstaWeb. Git InstaWeb is the web server built into Git, and I know you've never heard of it because we don't use it. We use GitHub instead. But if you launch Git InstaWeb and it was listing the repository that you have, there's that repository name. There's a couple of other log files, the commit edit message. This is the file that it passed into the hook. And so you might see git edit message, you might see git message, you might see orig heads sometimes, you might see info/refs. Here's another log file that's kind of kicking around. But that is all of the files here inside the .git folder. Now, we didn't talk about all the commands that you can do with Git, but we talked about all of the files here in the folder. As you look through this, here's the last piece in this repository, in this gist, is a list of each of those files and the description of what it does. So as you're referencing this later, then you can pull this open and dig into that part. This gist is up here that shows all of the content, including the visualization tool. And this gist you can get to from robrich.org. Click on presentations and it'll get you straight there. It's been really fun getting to dig into the .git folder with you. I hope this unlocks some of the things, and I hope it's a little bit more effective now when you have these really weird commands like update ref. What is it? It's changing the files in the refs folder. Thanks for coming.
Very much. Thank you very much. Does anyone have a question? Yes.
Thank you. Hello. Thank you for a great presentation. But if I did happen to commit the secret in the end, do you have a solution for that?
Yes. Change the secret.
What about reset?
How do I reset?
Hard reset.
Yeah. So I've got this file. Let's come in here to this .git folder. And let's take a look at what if we put a secret. So we've got this secret in place here, and it's like, well, how do we uncommit this? Well, right now we haven't committed it, so it's safe. We can delete it out of this file, and everything's fine. But CLS, git add file, what file was it? Git status. Git add file 2. From now on, Git will keep this secret. What if I go delete the blob itself? Good call. So I'm going to come in here and I'm going to get really aggressive. Let's show the type, parent child, show the line, show the tags. It's this one, C63D5C9. So C6. Okay, it's gone, right? Show the type, parent child, show the lines, show the tags. Now it's gone from my repository. Did I push yet? If I pushed, you may already have this commit. And so, yeah, I cleaned it off my machine, but it's still not gone. The moment that you commit a Git secret into Git, consider that secret lost. I know that's a painful choice, but that is the safest choice. Great question. Thank you.
So for now, unfortunately, it's over. Maybe you can write the next questions to the email address. And I want to thank you. It was great having you. And for you, I wish you a great evening. Goodbye.
Thanks for coming. Only 10 minutes over. That bad?